Last section of chapter 4, we're going to look at section 8. Now this deals with application and models. In other words, word problems.
Yes.
Okay? Some of them are not too bad. Just make sure you got your terminology down. For ones like this where they flat out give you the drawing you need to use, solve the right triangle shown in the figure where A equals 20, B equals 15. What are they actually asking you to do? Find all the angles and all the sides. So find everything out about it. So for this, well, they're usually going to give you 3 pieces of information because you need at least that much. So they give you A is 20 degrees. They give you B is 15. What's the third piece of information they give you?
90 degrees.
The 90-degree angle. So, easy one first. What's angle B? 70 degrees. Okay. What side do you want to find next? C. In order to find C, which trig ratio are you going to use? Cosine. So cosine of 20 degrees is equal to what? 15 over C. Adjacent over hypotenuse. So when you go to solve that, C is going to equal what exactly?
Cosine of 15 divided by the cosine.
Yeah. It's going to be 15 divided by the cosine of 20, because if you multiply by C and divide by cosine of 20, so then C is approximately what to 2 decimal places? Say again? 15.96. Everybody else get that?
Oh, wait.
Yeah, make sure you're in degrees for these. Then what would I do to find A? You could use Pythagorean theorem. I wouldn't. Why not? No.
Because of the C is
Yeah, C is rounded. So you're compounding rounding errors if you do that. Try to avoid compounding rounding errors. Okay? So instead of Pythagorean, what else could you use? Tangent. Yeah, you know the B here to find A. Those are opposite and adjacent. So tangent of 20 degrees is opposite over adjacent. So then what's A? Yep, 15 times the tangent of 20 gives you 5.46.
Yep.
There's the 3. So some of them are that easy. Some of them require a little bit more interpretation. Okay? When they give you the actual diagram, it makes it very simple. Some people can get thrown, though, when you have to generate the triangle yourself. Okay? A ladder that's 16 feet long leans against the side of a house. Find the height of the H from the top of the ladder to the ground if the angle of elevation of the ladder is 74 degrees. Okay? So if the house is here, going out to the ground, well, where's the right angle at? Bottom left. Where is the 16 feet at?
the ladder.
The ladder, the hypotenuse. So this is 16 feet. And where's the 74 degrees at? Bottom right corner, angle of elevation from horizontal up. So what side are they then asking you to find? The vertical, yep. The vertical from the ground up to the top of the ladder. That's H. So what trig ratio am I going to set up? Sine. So sine of 74 is equal to? Opposite over hypotenuse. So H is what? 15 point what? 38. What would be the units? Feet. So even those aren't too bad. Make sure you have the idea of angle of elevation, angle of depression straight in your head. Some of them require multiple triangles to be able to solve. From a point 65 feet in front of a church, the angles of elevation to the bottom of the steeple and to the top of the steeple are 35 degrees and 43 degrees, respectively. Find the height of the steeple. The tower on the top of the church. Okay? So, if I'm going to draw this, I'm going to draw the church up to the bottom of the steeple, and then the rest of the way up to the top of the steeple. Actually, make it even. Okay? You are standing 65 feet away. You're looking up at each value and figuring out the angle. So if I have 35 degrees here and 43 degrees here, what am I actually trying to find? Height of what? So where's that at visually here?
It's that little section.
Yeah, that top little section there. Then the problem is, I'm going to use this right triangle, and I also need to figure out the height from the top all the way down to the ground. Okay? Because if I find that, then I can do what to get h? Subtract what?
The total minus the thing bottom. Just the part.
Minus just the bottom part. So if I label these as y and x, I can just do y minus x. So I need to set up two different trig functions, trig ratios. One for y, one for x. So for y, what is the trig ratio going to look like?
Tangent 43 equals y over 65.
Equals y over 65. And then the other one? We tangent of what?
35
Is equal to?
x over 65.
X over 65. Is it right? So, what's y?
Y is tangent 43 times 65.
So what is it?
60.61.
60.61. What about for x? 45.51. So then how high is the steeple?
$15.1.
15.1. What was the question, John?
The height of the
Oh, yeah, the height of the steeple. Yeah, okay. Yeah, 15.1 feet. Okay. Those ones still aren't too bad. Neither is the next one if you actually slow down and make sure you pay attention to how you're drawing the thing. From the time a small airplane is 100 feet high and 1,600 ground feet from its runway, the plane descends at a straight line to the runway. Determine the plane's angle of descent. Angle of descent is the same as angle of depression. Okay? So, it's 100 feet tall, or 100 feet off the ground, I should say. And from the runway is 1,600 feet. Where would the angle of depression be on this? The angle of descent, I should say. What? It's right here?
No, it's the opposite. It's like if you draw a vertical straight out.
If you draw a horizontal out from that,
That's what I meant.
your angle that you're looking for is actually here. Now, where else does that angle occur? Bottom right. Angle of elevation from the runway up to the plane is equal to the angle of descent from the plane down to the runway. Now you could also just draw it differently. I could have just drawn the vertical over here and then the 1,600 feet through the air. But that's kind of counterintuitive because, well, it says ground feet. So what's trig ratio? Tangent. Tangent theta is equal to 100 over 1,600, or in other words, just 1 over 16. Theta is going to be what? .58 what? Degrees. Yeah, in any of these real world problems, it's pretty much always going to be degrees, just because we usually have a better visual in our head for what 45 degrees is rather than what pi over 4 radians is. Depends on the way the question's phrased, but possibly.
What do you mean?
No.
So like on the test, I had a problem about an airplane. But I get it wrong. I told the pilot to go down like what's pi over 12 radians.
Typically, you're going to do degrees.
If you're in mission control, if you're in the tower, you're like descending approximately pi over 12 radians. You're gonna like, I don't know what that means. Trash. Even though most of it's on here.
Okay, so now here's where. These are the ones that take a little bit more work. They aren't too bad when they give you the drawing. When they don't, though, they become a little challenging. Now, this talks about bearing. Now, bearing is always a measure of how far off the north-south line you are. So they'll always say 16 degrees west of north, things like that, or north 16 degrees west. What that means is, well, in this case, let's actually go through this one. Sailboat leaves a pier and heads due west at 8 knots. After 15 minutes, the sailboat tacks, changing course to north 16 degrees west at 10 knots. Find the sailboat's bearing and distance from the pier after 12 minutes on this course. Okay? Now, this 16 degrees west, or north 16 degrees west, I should say, is referring to, here's north-south line at B, and it's 16 degrees west of that north. So this measurement right here is 16 degrees. That's kind of hard to see. So this right here is 16 degrees. Okay? That's what the bearing thing means. Now, the problem is to be able to figure this out, I need to figure out how long these lines are. Now, I have a speed and a time. 8 knots is 8 nautical miles per hour. So after 15 minutes, how many nautical miles would it have traveled? 2. All you literally do is take 8 knots times what? 1/4, because 15 minutes is 1/4 of an hour. Gives you 2 nautical miles. Okay, that's how long it is from A to B. What would I need to multiply to get the distance from B to D? So it travels for 15 minutes, it travels this way, straight west out of the pier. Then turns 60 degrees west of north and goes up here to where it's at the current time. How long is that line from B to D?
10 times 3/15.
3/15 or?
12. Or, no, 12.
Never mind. Hold on. Math is hard.
You're right, but go the easy way, which is down to 1/5.
That's what I meant.
Okay.
I was getting there.
Yeah, it's just 1/5. 12 minutes is 0.2. So take 10 knots times 0.2, giving you 2 nautical miles. Okay? So then, the problem here again is they're asking me for the length of this hypotenuse, or of this big right triangle, as well as its bearing. Well, to do that, I'm going to figure out a couple values here. I want to find this angle. I also want to find that length. Now, there's a couple ways you can go about it. Easiest one, since I have a very finite number of measurements here, I mean, I could do something with law of cosines. We haven't talked about it yet. Some of you remember it, some of you don't. So what I would do instead is figure out these lengths. Because if this is 16 degrees, what is this angle right here? 74 degrees. So I can use that 74 degrees to allow me to find B and D. Okay? Which trig ratio would you use to find B? Sine. So I'm going to set up sine of 74 is equal to opposite over hypotenuse. And then cosine of 74 would be equal to what? Yeah, D over the 2. So, what's B going to be?
B is going to be 0.92.
And C? .55? Okay. So then, what would I do from there? That would give you the entire length from A to C. So 2.55. Then? With what? For A? Okay. Which trig ratio? Tangent. Hypotenuse is the one thing you don't know. So tangent of that angle A is equal to what? Yeah, B over that AC, right? Now, to be able to avoid rounding errors, I'm actually going to put into my calculator 2 times the tangent of 74, because that's B, over 2 plus 2 times the tangent, or not tangent, sorry, sine of 74. That's why I don't write in pen. 2 plus 2 times the cosine of 74. That's going to avoid rounding errors. Because this is, tangent of A is equal to side B over here
Yeah.
over that A plus C, right?
Yep.
So for that, B is equal to 2 times sine 74, right? So I'm just going to leave that in there like that. Instead of having rounding to 1.92, I'm going to leave it like that. For this side, D, this portion, is equal to 2 times cosine of 74. You need to add on the line from A to B, which is 2. So that's the way I would go about it to avoid any possible rounding errors. So you're going to do inverse tangent of that entire thing. Yeah, but that you're going to be able to plug into your calculator. You're not going to be asked to do this kind of problem without one.
Yeah.
So I would make sure, though, to have parentheses. What do you end up getting for the width, or the angle, I should say, for A? Anybody else get that? Anybody else see something different? 47? 37. What'd you say? Oh, I misheard you. Okay. 37 degrees. Okay. So that means this little angle down here is 37 degrees. Now, I still need the actual length of C. How would I go about that? Sine?
Sine of 37 equals 2 times sine of 74.
Because that's that B, that's that opposite over
C.
C. So then C is going to be equal to 2 sine 74 divided by sine 37. So what do you get for a length of C?
Got it.
3.19? Anybody else?
Yeah.
What would be the units on that? Nautical miles. Okay, so then my answer says find the bearing and the distance. Well, I got the distance, but I don't actually have the bearing here. Okay, bearing is always how far off of north or off of south you are. So, at A, that's where the pier was, right? How far off of north is this line?
37 degrees.
No, that's how far north of west it is, but I want to know how far off of north it is.
Don't even tell me 53.
Don't even need.
53 degrees, and then what would I put around it? Yeah, north 53 degrees, west. So that's your bearing and your distance traveled. So if I wanted to go straight out to where the boat is currently, I would take a bearing of north 53 degrees west and go for 3.19 nautical miles. Yeah?
Is it okay if instead of like that notation you write out like west of north?
Nope.
No, we have to like.
You need to use the bearing notation.
Alright.
And it's always north.
Am I gonna need to
50,
do this?
or like north degrees.
question.
West or east, or it could also be south.
You're telling me?
If it's
Degrees.
Like over 45 degrees. Like
Well, or if you're facing south. From whichever one's the bearing is never gonna. You're never gonna have a measurement that's more than 90 degrees.
Okay.
Okay. When they're doing bearings, you're never going to have a measurement that's more than 90 degrees.
So how would I get south?
If it's facing the opposite.
If you're literally, it's closer to south than it is to north. So if you were going down here somewhere, like if I went from D to, if you went from D to A, this would be, what is that? Yeah, that would just be 53 degrees east of south. If you were going from the boat, the bearing back to the pier would be 53 degrees east of south, or S, 53 degrees E.
North can also be south. It can be either how far you off the north or how far you're
Yes.
off the south. Okay. That makes sense.
Okay. Now, you will also get to ones that are aeronautic. In other words, planes. When you're doing planes, they use a completely different bearing system. They do how many degrees you are off of north clockwise. So straight east is 90 degrees bearing for a plane. South is 180, west is 270, and all the way around like that. So it depends on whether you're doing planes or you're doing boats.
Are we gonna have to memorize?
You will have to know that.
Oh boy.
You will have problems dealing with it in this in this section, a fair number of them. And yes, on the test, if it's boats, you need to answer the proper way. If it's planes, you need to answer the proper way.
I signed up for pre-calc, not navigation.
Too bad.
So there's just gonna be one of like either or on the test.
I don't know.
Are they gonna be two?
I don't know.
I don't like this.
It's not that bad once you're used to it. Trains don't deal with bearings.
I don't know anything about that.
Not this kind. Ball bearings, sure, but directional bearings, no. Okay, harmonic motion. Now, harmonic motion is something where it bounces back and forth between two values. If you actually track this kind of motion over time, what would you get? Sine wave or cosine wave. So, if you have a ball that's bobbing up and down on a spring, it has a null state right in the middle called equilibrium. You can stretch it to its maximum negative displacement. If you let go, it would rise to its maximum positive displacement. Okay? So the idea is to actually create an equation for this. Now, for simple harmonic motion, not having to deal with any kind of phase shift going on with it.
You okay?
Okay? Distance d from the origin at any given time t, well, is going to be given by this formula. Alpha is equal to sine times, they use omega here, lowercase omega for, if you think of that as b, that's fine, times t. A and b have to be real numbers, the amplitude is a still, period would be 2 pi divided by whatever's in front of the t. Frequency is going to be the reciprocal of that. Okay? So if I have a simple harmonic motion and I know this much data about it, okay? Displacement t equals 0, or at t equals 0 is 0. So it's starting at equilibrium. Okay? If it's starting at equilibrium, which is going to be better to use, sine or cosine? Sine. Because that's just like starting at the origin. If you're starting at maximum displacement or minimum displacement, that would be, or positive displacement or negative displacement I should say, that would be cosine. So because of this, I would use sine. Now, this asks, what is the frequency of the harmonic motion? Well, the amplitude is given to me as 4 centimeters. It also gives you the period is over 6 seconds to complete one full cycle. So if I know the period is 6 seconds, I can set that equal to 2 pi over, well, this uses omega. If you want to still use b, that's fine. So then the period of the function is 6. What's that b value? We'll just solve for b. What would b be equal to? 2 pi over 6, which simplifies down to pi over 3. So that b value is pi over 3. Okay? Now, the frequency would be what? Remember, frequency is just reciprocal of whatever the period is. So what's the period? Period is 6. So what's the reciprocal of 6? 1/6. So your frequency is 1/6. Whoops, I wrote a 2 for some reason. Frequency is 1/6. What would the equation of this be? Found the period already. We know the amplitude is equal to 4. So 4 times. Yeah, they use T and D for this, but yeah. So that would be your model. The frequency would be 1/6. Does that make sense? All right. Looking at one more of those, go ahead.
So if it would have been a 1 after the displacement, it would be cosine.
Well, it would have to be a 4. Why?
Oh, because the amplitude.
Yeah. Because of the amplitude, if it's a 4 or negative 4, I would go with cosine.
So then, is it just like the same way of going through to solve it?
Yep.
And just
The exact
cosine?
same way.
Got
Yep.
it.
Okay, so for this one, given the equation of simple harmonic motion, so I'll give you the equation this time. What would the maximum displacement be? 4. It's whatever that amplitude is. That's how far off the equilibrium you can be. What would the frequency be? Now for this, it's the reverse of what, to find the period, you do 2 pi divided by whatever's in front of the t, right? So for this, you do 6 pi here is going to be over 2 pi. Frequency is that b or omega over 2 pi. So what's that give you? 3. So the frequency is 3. Find the value of d when t is 4. So plug in 4. Now, honestly, I wouldn't even bother with the calculator here because it's going to be cosine of 24 pi. What's the cosine of 24 pi? Well, because it's even, multiple of pi, it's going to be the same as cosine of 2 pi. So 1. So you have 4 times 1, which is 4. So C is 4. Okay. Find the least positive value for which t for which d is equal to 0. Okay. So I'm going to plug in 0 for d. If I take 4 times the cosine of 6 pi t is equal to 0, what do I do first? Divide by 4. That gives you 0 is equal to cosine of 6 pi t. Well, when is cosine 0? Think unit circle. When is cosine 0?
Pi over 2.
Pi over 2 or
Negative pi.
negative pi over 2 or 3 pi over 2. Which was the least positive one of those?
Pi over 2.
Pi over 2. So pi over 2 is now equal to 6 pi t. So, I'm sorry. Pi over 2 is now equal to 6 pi t. Yeah. Divide by 6 pi, or I would just multiply by 1 over 6 pi. Because when I write it that way, what cancels? The pi's. And you're left with 1/12. So time is 1/12. So 1/12 of a second later is at equilibrium. Questions? Okay. It's all for chapter 4.